Hey there, my name is Neil Collins, and today I will be presenting my project on the trig functions and right triangle trig ratios. So today here we have the unit circle and the right triangle, which is in the unit circle. Here it is labeled A, B, C. Here we have the unit circle, or the right triangle in the unit circle, and we are using SOHCAHTOA, sine opposite hypotenuse, cosine opposite adjacent, and tangent opposite adjacent. Or cosine adjacent hypotenuse, and then tangent opposite adjacent. And right here, right in this unit circle, we have delta and delta over here in the right triangle. See how these correspond with each other. And what we're going to try to do is see which expressions correspond with which angle in the triangle. So we have right here sine CBA, CBA. We are trying to find the sine of this angle and which expressions would represent that. Okay, so to get started here, we are going to start off by labeling the x adjacent. Adjacent, and then the y is the opposite. So from this delta, this is the adjacent, the x, and the y is going to be opposite. Perfect. And then this hypotenuse is going to be a 1 because the radius is 1 of the circle. So therefore the hypotenuse is 1 as well. And then from there we know that the x and y stand for cosine and sine. So the x is going to be the cosine of this angle right here. And the y is going to be the sine of this angle delta right here again. Okay, so we're going to start off with x over 1, this expression right here. So x over 1 is going to be x, the adjacent, over 1, the hypotenuse. Opposite, or adjacent over hypotenuse, is going to be cosine. Therefore, x over 1 is cosine of delta. Or theta, sorry. I don't know why I said delta. It's theta. Okay, and then from there we are going to write in this cosine of delta. Okay, perfect. Next off, we are going to do this expression right here, y over 1. Y over 1 is going to be opposite y over 1, the hypotenuse. So I can just write it out and show you guys. Opposite over hypotenuse. And this is going to be equal to sine of that angle delta. Perfect. Next off, we are going to do x over y. Adjacent over hypotenuse, x over y. Adjacent over, adjacent over opposite. Perfect. Adjacent over opposite is going to be nothing because that is not in SOHCAHTOA. Opposite over adjacent, nope. Adjacent over hypotenuse, nope. Opposite over adjacent, close but still not yet. It's actually the opposite of tangent, which would make it a cotangent, or 1 over tangent, of theta. Perfect. So that is not an option, that's a no. Now we're going to go ahead and try y over x. Y over x, opposite over adjacent is going to be tangent, right? In SOHCAHTOA, we have opposite over adjacent, which is tangent. So that is going to give us the tangent of theta. Perfect. Okay. Now we're gonna go ahead and try a over b. A over b. So now that we're done with the triangle over here, we're gonna compare it to the equivalent over on the right side. Okay, so a over b. A over b is going to be, so over here, let's label this triangle just to make it easier on us. This side right here with A is going to be the adjacent. This side right here, B, is going to be opposite. Since this side B is on the opposite side of theta, and this side A is just like right under it, but it's not the hypotenuse, therefore it's the adjacent side. And then C, of course, is the hypotenuse. So that's the first time which would most likely be 1 if it was the same right triangle. We are going to see about that. Okay, A over B. So A over B, A over B. Adjacent, right? Over opposite. Adjacent over opposite. That is unfortunately not a tangent. That is the opposite of tangent. Once again, making it cotangent, or 1 over tangent of theta. That is another option that we have to cross out. Since it could be a cotangent of CBA, but we're specifically looking for tangent, not cotangent. So that one is not going to be of any use to us today. The next one we are going to go over is B over A. B over A is going to be opposite over adjacent. Opposite over adjacent. Which is going to be equal to tangent of theta. That's going to be another tangent. Let's just go ahead and highlight all of them. Okay, perfect. Now we're going to go ahead and try C over A. So C hypotenuse over A, the adjacent. So it's going to be hypotenuse over adjacent, which would be the complete opposite of cosine, which would make it, once again, a cotangent. Or not a cotangent, it would be 1 over cosine of theta. Perfect. So this one, once again, is not going to be any use since we are not using the opposite of cosine. Okay, the next one we're going to try out is A over C, adjacent over C, the hypotenuse. So we know now, after doing a few examples, that adjacent over hypotenuse is going to give us a cosine. So that would be the cosine of theta. As we can see here, adjacent hypotenuse, cosine. Just, if you guys forget, just go ahead and look at your SOHCAHTOA, and that'll help you right out. Okay, the last term we're going to try out is going to be B over C. B over C, opposite over hypotenuse, is going to give us sine of theta. Perfect. Now that we have all of these expressions kind of solved for, and we know whether it's the cosine, sine, tangent, cotangent, however it may be, of these specific angles over here, and now we are going to match them up. And the ones that we crossed out, which are not kind of on our list, we're not going to use. Okay, so sine, we're going to do the same as we did over here with the sine. It's going to be the sine of angle CBA. We found the sine of delta. Cosine of delta. And it's going to be the same thing over here. The tangent of delta. Perfect. Okay, so for this, we have to figure out which angle matched up with the sine. Right here, y over 1, as we figured out earlier, y over 1 opposite over hypotenuse is going to be a sine. So we'll put that in there. However, we're going to look for, see if there's any others. B over C is also the sine of theta as well. So B over C is going to be categorized in that. So y over 1 is equal to B over C. What we were trying to do in this activity is basically figure out which, just kind of improve our skills on trig functions and trig ratios and kind of match the two up. So as you can see here, we were able to figure out which expressions were the sine, cosine, and tangent of this angle. And we did the same thing over here, just a triangle and a unit circle using the adjacent and the opposite x and y, and that hypotenuse, which is 1, which we know because it's the same as the radius. Okay, so now we're going to move on to cosine. So what expressions gave us the cosine of angle CBA? For starters, x over 1 over here, x over 1 adjacent over hypotenuse gave us the cosine. So x over 1 is going to be one of our expressions that we're going to be using today. And then secondly, we also figured out that a over c is also going to give us a cosine of our angle theta, right over here. Now tangent of angle CBA. So we have to figure out which expression gave us the tangent for CBA angle theta, both angles right here. For starters, we found that y over x, right here, y opposite over x adjacent gave us a tangent on this side, tangent of angle theta, and then the equivalent to this would be the angle b, or the expression b over a, over here as we can see, b over a will once again be opposite over adjacent, giving us tangent of this angle theta once again. So now we have found all of these expressions right here. We figured out how to match them, how to find them, how to understand how SOHCAHTOA applies to both a right triangle and unit circle, and just how it applies to trig functions and right triangle trig ratio. I appreciate you watching my video, and I hope I did the best I could explaining it. Thank you for watching.